Hey, beautiful people, Sean Walia here for Sean Walia Math. Today, I'll be teaching you how to solve a linear system using the technique of substitution. So let's do this. All right, so you wanted to learn some substitution, huh? Some substitution techniques to solve linear systems. Well, you came to the right place. I'm gonna hook you up for a small fee. Your attention for about 10 minutes. Hey, okay, so here you go. Here's a linear system. What is a linear system? It's essentially two equations, two unknowns. Both are linear equations because all of our variables are to the power of 1. The technique of substitution, very basic. Essentially what you do is you isolate a variable in one of the equations. Now, what you may be noticing is that y has already been isolated. So this one's good to go. Since it tells us that y is equal to 5x minus 7, I can take that result and I can substitute that into the other equation for y. If I do that, I'll get negative 3x minus 2y, y being 5x minus 7, equals negative 12. Now, what you might notice at this point is that now it's all in terms of one variable, and I can isolate x and figure out what it is. So I'm going to get negative 10x plus 14 is equivalent to negative 12. Combining like terms, I'll have negative 13x plus 14 equals negative 12. Bring the 14 to the other side, and I get negative 13x is equivalent to negative 26. Finally, divide both sides by negative 13, and x is equal to 2. Okay, now that I've figured out what the x value is, I need to figure out what the y value is. So I'm going to go back to this equation here because y is already isolated, and I will substitute in that x value. When I do that, I get y is equal to 10 minus 7, or y is equal to 3. Perfect. So our solution to this is 2, 3. Okay, so in this example, y was isolated, it was ready to go. But what if y isn't isolated, or how do I know which variable to isolate? Well, let's take up another example. So say we have the linear system negative 7x minus 2y equals negative 13, and the other equation being x minus 2y is equal to 11. So look at all the variables. We got x and y in this equation, x and y in this equation. You should be looking for the variable that has a leading coefficient of 1, because that will be the easiest one to isolate. So that would be x in this equation. All the other variables require 2 steps to isolate, and you're also going to run into involving some fractions, which will be more difficult to do computations. So I'm going to isolate x in this equation by adding 2y to both sides. Now I have x equals 11 plus 2y. I'm going to take that result and I'm going to substitute that in for x into the other equation. I'll get negative 7, open bracket, 11 plus 2y minus 2y is equal to negative 13. Now I can isolate x. I get negative 77 minus 14y minus 2y is equivalent to negative 13. I'll combine like terms. This will be negative 16y. Negative 16y minus 77 equals 13. I'll add 77 to both sides, and I will get 16y negative is equivalent to, what am I going to get there? Sorry, that's negative 13. Let me just erase this so you're not confused. Negative 13. 7 minus 13 is positive 64. Divide both sides by negative 16, and you get y is equal to negative 4. Now that I know y is equal to negative 4, I'm going to substitute that into this equation, and I'll be able to figure out what x is. 11 plus 2 times y. That's going to be x equals 11 minus 8, and that is 3, giving us a final answer of 3, negative 4. So just a quick recap: isolating a variable in one of the equations, substituting it into the other, simplifying or isolating y, and then substituting it back into that equation to figure out what x is. We'll do one more example. Okay, and this of the three would be the most sophisticated, Because all of the variables have coefficients other than 1. So you want to isolate the variable that I think is going to be the easiest, but also is going to not have as many fractions being involved. Oh, forgot an equal sign there. 1 sec. It's negative 7x plus 8y equals negative 5. Okay, so the process of isolating a linear equation, you're going to bring one term to the other side, then divide both sides by what's attached to the variable. I think the easiest one to isolate in this equation here, because when I bring that 6 over to this side and I divide everything by -2, both of these values are divisible by 2. Say I isolated x in this equation, I would bring that to that side, divide everything by 7, and it wouldn't divide in evenly. So I want to make a good choice here. So I'm going to isolate the x by first bringing 6y to the other side. Negative 2x is equivalent to negative 6y plus 6. Then I'll divide everything by -2. And as you can see, it divides in evenly. We get a nice expression with no fractions for x. We then take that, substitute it into x for our other equation. And now we have an equation where we can isolate y. Okay, so we're going to get negative 21y plus 21 plus 8y equals negative 5. Gathering like terms, we are going to get, I believe that's negative 13y plus 21 equals negative 5, minus 21 from both sides. Negative 13y equals negative 26. Divide both sides by negative 13, and I'm going to get y equals 2. Okay, great. I found that y is equal to 2, but I still haven't found x. I've got to go back to this equation and to solve for x, and x is equal to 3 times 2 minus 3. 3 times 2 is 6 minus 3. X is 3. So our final answer is 3, 2. And there it is, you guys. That's how you solve linear systems using the substitution technique. I hope you liked the video. Please subscribe if you enjoyed it. And of course, hit the like button. If you have any requests of any particular math lessons you'd like me to do, feel free to leave those in the comments. But other than that, thanks for watching and have a great day.